Good afternoon, everyone, and thank you for joining us. My name is Sarah El-Ghaziri. I am the Digital Communications Officer at EDF, and I'll be moderating today's session. Today, we'll be discussing EDF's unique experience in pumped storage hydropower development in the Middle East and the role this technology can play in delivering flexibility for a net zero carbon future. Before we begin, I'd like to quickly go through a few housekeeping items to help you get the best experience from today's webinar. Throughout the session, we encourage you to use the chat and Q&A tools to share your questions and comments. We'll try to address as many questions as possible during the live discussion, and if needed, we'll follow up afterward. You'll also find a survey available at the top of your screen by clicking on the word survey. We would really appreciate your feedback, and you're welcome to complete it either during the webinar or at the end of the session. A copy of today's presentation materials and additional resources will also be available in the related content section of the platform. Please also note that today's session is being recorded and the recording will be shared after the webinar concludes. I'm now pleased to introduce our speaker for today's discussion. Joining us today is Dr. Yves-Laurent Beck, Senior Business Developer, Hydropower Projects at EDF Power Solutions Middle East. So Yves-Laurent brings more than 20 years of experience in hydropower and dam engineering, infrastructure monitoring, and asset performance optimization. Throughout his career at EDF, he has contributed to the development of innovative monitoring technologies and supported major hydropower projects, combining deep technical expertise with extensive international experience. Now that everyone is settled in, let's kick off today's session. Yves-Laurent, thank you for joining us today and for sharing your expertise with us. I'll now hand over the floor to you. Yves-Laurent, the floor is yours.
Thank you, Sarah. Thank you. So good afternoon, everybody. So I will talk about EDF unique experience in pump hydro storage in Middle East, and I will present you first how it works. But maybe first I will present you what is EDF and EDF Middle East. So in fact, I'm working at EDF Power Solution, and EDF Power Solution is the main foreign investor in Middle East on renewable energy after Aqua Power and Mazda. And you can see here on the screen the number of projects what we have been awarded, who are under construction, who are in operation, under construction, or under financing. And we just have been awarded 2 days ago for 500 megawatt of solar PV in Oman, but I didn't put it in my slide. So what is EDF Hydro? EDF Hydro is the EDF Hydropower branch in EDF SA. And we own and operate more than 23 gigawatts of hydropower capacity, mainly in France, but abroad also. We own and operate more than 400 hydropower plants, and it represents around 600 dams. We have around 5,500 employees who are working at EDF Hydro. And on this fleet, we own and operate all the main pump hydro storage assets in France. It represents 6 pump hydro storage assets, and the cumulative capacity is 5 gigawatts. It's important to mention that at EDF Hydro, we have our own inner EDF Hydro engineering, who involve in more than 40 gigawatts of pump hydro storage projects worldwide. And today you have a quarter of this capacity who is under operation. So, sorry, and this is a photo of each pump hydro storage project in France. And the 6 main pump hydro storage projects, in fact, we have 5 gigawatts, as I mentioned before, and half part is for weekly flexibility and half part is in daily flexibility. So in fact, we have the both expertise on the weekly and daily flexibility for pumped hydro storage. And today you have a new plan, a new strategic plan in France, and we will build some new pumped hydro storage capacity. And the next project will be around 1.5 gigawatt of project in pumped hydro storage in France. So pumped hydro storage development in Middle East, what is the need and what is the principle of the pumped hydro storage? So in fact, why we have to develop pumped hydro storage in Middle East, I take an example for UAE, but it's exactly the same strategy and the same order of magnitude for Oman, for KSA, or for Jordan countries. In fact, we have a continuous expansion of the solar PV fleet. And due to that, in fact, we need flexibility. So we need flexibility to avoid curtailment costs. So we need storage. And for example, I made a cross calculation for UAE. In fact, the annual UAE curtailment cost, if we don't have any storage of energy, in 2037, it will be around $1.5 billion. So we really need storage. So in fact, of course, you have the batteries, but we can have the solution with a pumped hydro storage. So we need flexibility and we need auxiliary services. So auxiliary services included network frequency and voltage control, black start, reverse generation, and step ramping. So the aim, in fact, in Middle East is mainly to integrate the renewable energies, intermittent energy, and typically is to store the energy, the solar PV energy produced during the day, and to use it during the night. So this is an example. I like this chart because it's in Japan. The electricity market in Japan between April 2010 and April 2020. You have in yellow, it's the apparition of the solar PV fleet. And in light blue, you have the use of the pumped hydro storage. So it's close to zero. I don't know if you see well my slide, but in fact, it was well used. So they have a lot of pumped hydro storage in Japan. And in fact, you can see that you have a rise of the use of the pumped hydro storage linked with the solar PV increase. And of course, you have a decrease of the use of the thermal fleet, so CO2 reduction on the power generation fleet. So how it works? So a pumped hydro storage, you understood that it's working like a giant battery. So the principle is simple. In fact, you need two reservoirs, one upper reservoir and one lower reservoir. And in Middle East, the PHS stores the excess electricity generated by the PV solar power during a day. By pumping the water from the lower reservoir to an upper reservoir. And when the electricity demand increase or solar generation decrease, the stored water is released through the turbine and to generate electricity. To conclude, this is therefore allows the energy produced during a day by the solar PV, and we transfer to the night. More the gross head is high, more you can store energy. Obviously, more you can store some water, more you can store energy. And you have a new technology with the variable speed pump turbine. So new in Europe, in fact, it's not new in Japan, but it's quite new technology with a variable speed pump turbine who enhance the system by enabling more efficient operation over a wide range of power level and improving the grid stability and increasing the operational flexibility. and you can maximize the integration of the intermittent renewable energy. So the lifespan of pumped hydro storage is more than 80 years. So I like to say that it's around 100 years of operation. You need maybe after 40 years or something like that, it depends on the water, on the configuration of your asset and so on, to have a rehabilitation of your a part of the electromechanical equipment. And today you have 95% of the worldwide total energy storage capacity is done by pumped hydro storage. And you can store some water, some energy for more than 10 hours of storage capacity. And the round trip efficiency, it's important between if you have a full round trip efficiency for pumping plus turbining with around 80%. So you have two types of pumped hydro storage. You have the open loop and the closed loop. So the open loop, in fact, you have a river or an intake of water in one reservoir, and the closed loop is no real natural and constant intake of water. So in fact, the closed loop is off river, and in fact, in Middle East, we will have only some closed loop project. So I'm working in Middle East, and when I'm discussing with my friend, in fact, they are laughing about me because I try to develop hydropower in arid region. So of course we don't have a lot of water in this country, or whether you have some water. So you have some natural fresh water, such as in Hatta, where we developed the first pumped hydro storage in Middle East, in UAE. And you have other reservoir in each country, and I'm discussing with all the government and in each country, such as Jordan, KSA, UAE or Oman, you have some reservoir, and typically in Oman you have Wadi Dekadam with 100 million cubic meter capacity reservoir, and it's very huge. So you have some fresh water, existing fresh water, and you have other projects in Middle East, and we are thinking about desalinized water. So we will have a first filling of the reservoir. You can include it in the capex and opex, and it's bankable in this project. For you Western people, of course, desalinized water is not an habit, but typically in Middle East, we have a lot of capacity of use of production of desalinized water. So it's possible to build one project like that. And the annual water losses, if we accumulate the evaporation plus the leaks under the sealing phase of the reservoir, in fact, we can estimate the annual water losses around 10 to 20% of the volume of the reservoir. So of course, it depends on the depth of the reservoir and so on. So you can decrease this amount. However, it's not a lot. It seems to be a lot, but it's manageable. Typically, for Hatta, the active volume is around 4.5 or 4 million cubic meter of water. If you take 10% of that, it's only 1 day of desalinized water production of one desalinized plant in UAE. So in fact, it's not a lot. So you can manage the refilling, the annual refilling. And the last thing is, of course, everybody has in mind why we don't use seawater for the pumped hydro storage. So today, you had in an experience worldwide, the sole experience what hydropower community had was in Japan. They closed this pumped hydro storage. They use the sea as the lower reservoir. So it was a really interesting project. Today, it's closed because it's not bankable on the grid due to the electricity market in this country. However, it's possible to build it. So you have to deal with some issues such as the ENS issues, the environmental and social issue. Typically, we add one. We are thinking about this seawater pump hydro storage in one project. However, we had some natural water table, and we don't want to pollute it with some brine water. So in fact, it's a no-go for this project. So that's why we will use some desalinized water if this project is working. And you have another issue, ENS issue, is about biofueling. In fact, you will fill and empty every day the reservoir. And in fact, if you kill any biodiversity bioorganism in the reservoir, in fact, it will be a red flag for the for financing. So it's possible to build some seawater pump hydro storage, but you have several issues to deal. And typically in France, we have one project in Réunion, French island. EDF is working on a seawater pump hydro storage project. So this slide is only to mention that compared to renewable energy, in fact, pump hydro storage project is like a hydropower project. It's a long-term project. It's a long-term project, so we need between 1 to 3 years of development phase. And after that, we need 2 or 3 years, of origination phase. And after that, we need 2 to 3 years of development phase, because we need to launch some feasibility study. We need to verify the geology and to do some ENS studies, impact studies, and so on. And refine the design. And after that, we need between 4 to 6 years of construction. And after that, you can use this asset for a long term. And as I mentioned, we can use it until 100 years. So pump hydro storage project is a very site-specific project. So compare, for example, to batteries, where you can put some batteries everywhere and distribute it in the electrical network. In fact, it's not the same. So in fact, we need to identify where is the potential site with nice growth head, I will say, and with not too far between the both reservoir. And so we will do a site screening, and after that we have to verify, of course, the geology and so on. So we need a good geology, and we have to deal with the ENS issue. So the advantage of the pump hydro storage, I think, for the government is more the sovereignty. In fact, because 70, so for the sovereignty, because after to build a pump hydro storage project, in fact, you can operate, and it's quite easy to operate. I would say, if you have any skill transfer, in fact, you can operate this asset during the long term. You don't have a lot of maintenance, and the cost of the maintenance is lower than CCGT, for example. And the lifespan is very long, so you are investing for the next generation, of course. And the local content is very high, because I like to say that 70% of the cost of a pump hydro storage project stay in the country, because in fact you have around 70% of the cost of the project is around the civil works. Compared to batteries, for example, where you have maybe 70% of the cost who will go in the country who produce the battery, mainly in China, typically. And the other thing is in local content, in fact, in Middle East, when you are building a new freshwater reservoir, it attracts a lot of idea from everybody and from the government. And typically here you have in the you have some idea, so the Dubai plan 2040 plan around the lower reservoir of Hatta in Dubai, where they are thinking about a resort, about cable car and so on, and you can develop a lot of touristic activities. And typically, during the construction of this project, it's appear to have any activities, kayak activities on this site. And in fact, we have to deal. The project has to deal with that. and you have some constraint of operation, of course, and the use of the kayak couldn't be closest to the intake of the hydropower plant. So right now, we'll try to present you Hatta Pumped Hydro Storage project in Dubai. So in fact, we worked for DIWA. So in fact, it was EDF Hydro Engineering who worked for DIWA as the owner engineer. So it's the first of kind in Middle East. So it's the first pumped hydro storage project, and it represents 1.5 gigawatt hour of storage. I don't know why it's working. Okay, fine. So what is the EDF role in this project? In fact, we work from the preliminary studies to the construction, and we follow we monitor the construction as owner engineer. So we did the screening studies, the full design, the EPC tender preparation, the selection of the EPC, and after that, the technical assistance during the construction. So in fact, the owner and the operator is DIWA, so we were the owner engineer, and it has been built by a consortium of EPC with Oscar, Strabag, and Andritz. So today, in fact, is fully in operation. So where is Hatta project? In fact, in the border of in Dubai area, but in the border of Oman. In the mountain, and you add an existing lower reservoir who is a flood protection dam reservoir with around 8 to 9 million cubic meter of capacity, and we build the upper reservoir and the hydraulic circuit. So as all the hydropower project, in fact, we have some ENS issues. So in fact, an environmental impact assessment was carried out for the project, including the identification, the monitoring, and the protection of the plants and animal species present on the site. During the site investigation, in fact, archaeological remains were also discovered. And these artifacts are now preserved and exhibited in the museum in Abu Dhabi. So in fact, we were in a Ramsar area, so it's a protected, specific protected area in humid zone in UAE. So in fact, we have to take care about this kind of topic. So in fact, all is configured this pumped hydro storage. In fact, you can see on the middle of the slide the existing reservoir, the lower reservoir with a large dam. In the upper part of this slide, in fact, you have a second reservoir with more a buffer reservoir if we have a need of water. In fact, we have a link, we build a link between the two lower reservoir, I would say. Whether on the left, we build the upper reservoir. So this upper reservoir is new, and we build two dams, one main dam and one saddle dam in RCC dam, so a whole concrete compacted dam. And we build a hydraulic circuit, so a hydraulic tunnel between the upper reservoir to the lower reservoir. I will show you. So you can see here in the cross section, you have on the left the upper reservoir, on the right you have the lower reservoir, on the two of the right, in fact, you have the in open pit. In fact, we have an underground powerhouse. The powerhouse is always, so the turbine in pumped hydro storage should be under the lower level of the lower reservoir. So in fact, that's why it's always in underground. In fact, in pumped hydro storage, the powerhouse. So not always, but you have some exception, but it's always under the lower reservoir level. You can see here the construction of the hydraulic circuit, so high pressure hydraulic tunnel. It's a 1.2 kilometer of tunnel with a diameter of 8.5 meter. And the nominal water flow for pumping or turbining is around 220 cubic meter per second. So it's the equivalent of the volume of one Olympic swimming pool every 12 seconds. So it's huge. So here you have some photos on the upper reservoir large dam construction. So as I mentioned, it's RCC dam, so two RCC dam. In fact, you have to build this dam where you compact a mix of materials plus concrete, and you build it layer per layer, in fact. So it's quite interesting dam because it's quite easy to operate, and in this country, in fact, it's interesting to have some easy operating reservoir. It's important to mention that the upper reservoir is the highest, the main dam is the highest dam in UAE. Here you have the powerhouse construction phase. So it's an open pit, and we build the powerhouse in the open pit. You have two turbines, so that's why you have two holes in this photo with the spiral case. The spiral case, in fact, is built like that in hydropower, in fact, to maintain the same pressure around the turbine, the hydro turbine. And you can see that the turbine, the Francis turbine built in Germany in this photo. And one specificity in hydropower is we built and we have to build the very heavy rotor and stator. So the generator is built on site, sorry. And you can see the photo of the powerhouse today. So in 2025, in fact, we had the first filling of the upper reservoir, and we test during around 1 year this asset, and today the asset is under operation, so fully functional. So we are waiting for the transfer to DIWA for this project. So it's a real success on this project, and we stayed on the budget, on the initial budget on the construction for this project. And as I mentioned, in fact, in the lower reservoir during the construction, we saw some development of leisure activities such as pedalos and kayak. So in fact, we have to adapt whole project to this kind of constraint. So in fact, that's why we build a specific floating barrier to protect the kayak activities, and we help them to adapt the floating departure of the kayak. And we had one project with DIWA about a cable car until the Dubai Summit for this project. And my last slide is about the next PHS project in Middle East. So in fact, I saw someone well known in the list of the attendees, but in fact, I'm discussing with, I'm working on several projects, but the next one should be in Oman. In fact, 2 days ago, we signed with our consortium an agreement with the government of Oman for a framework agreement for this project. So it's the Jabal Abiad project in Wadi Dekadam. So in fact, we will use the existing lower reservoir. So the lower reservoir, it's a flood protection dam and then recharge dam, in fact. It's a 100 cubic meter of water capacity reservoir. And we have the project to build in the closest plateau at 1,000 meter high, the upper reservoir. So in fact, you can see in this figure, in fact, this is the project of the new reservoir with the hydraulic circuit with a full underground powerhouse. So it will be a cavern powerhouse with several pump turbines inside this powerhouse linked to the existing reservoir. So we are at around 1 hour by car to Muscat. We are in the north of Oman, so we are close to the consumption of electricity in Oman, and we are speaking about a potential storage capacity around 19 gigawatt hour during 9 hours of storage. And the active volume of this project is 8 million cubic meter of water in closed loop. So it's not a lot, I will say, but because in volume of water, because in fact we have a very important growth head with around 1,000 meter high. And today we are working on this project, and we expect to deliver it in the next years. Thank you very much. And this is the conclusion. So as I mentioned, the PHS benefits are the energy sovereignty, the renewable energy, it's a renewable energy and sustainable energy. We have the advantage to have the speed, availability, and flexibility. And it's a unique storage capacity can be provided by the pump hydro storage and the availability to provide auxiliary services to the electrical grid. Thank you very much. And if you have any question, do not hesitate.
Thank you, Yves-Laurent. We will now begin answering the questions submitted during the event. As a reminder, you can still submit questions through the questions pane in your attendee control panel. So let's start with the first question. You can put it on the screen. So the first question is, most PHS projects are developed as greenfield facilities. From EDF's experience, how do you view the potential of retrofitting existing conventional hydropower plants with pumped storage, pumped hydro storage, to reduce capital costs, shorten development timelines, and accelerate renewable integration, particularly in countries with aging hydropower infrastructure?
So thank you for this question. I will try to give the right response, but in fact, we are working on some brownfield project, in fact. So I don't know how to define what is a real brownfield or greenfield project, because typically here, as I mentioned, for the Jabal Abyad project in Oman, we are using an existing dam, so an existing reservoir. So we can consider that it's a brownfield project because we are using the existing lower reservoir as the lower reservoir of this project. In France, in fact, the next project, when I mentioned that we have a 1.5 gigawatt hour of 1.5 gigawatt of new project of pump hydro storage in France, it will be fully some brownfield project. So it's possible to build and to have some brownfield project in pump hydro storage. However, you need the good condition, site condition. So you need the growth head, you need the good geology. So you have to find where closest and we find closest to the existing hydropower plant, the good potential of another reservoir with a high growth head and sufficient volume of water storage.
Okay, thank you very much, Yves-Laurent.
Welcome.
Our next question is, do we always need fresh water for this technology? Can we use seawater nearby a cliff to apply such concept?
So that's exactly what I mentioned about the arid region. In fact, it's possible to use some brine water or some seawater. However, you have some issue for the ENS topic, and you can have any issue for corrosion too. Whether you can protect more your electromechanical equipment, so it will cost more, or whether it's possible to protect it. So we can study it. In fact, it's fully feasible. But you don't have, however, you don't have today one project like that under operation. So maybe for the financing, it will be more tricky to obtain finance by the international banks.
Okay, thank you, Yves-Laurent. Our next question is, what happens if we have 5 years without rain in Oman with 20% evaporation per year?
It depends for which project. In fact, for each project, we need a very strong hydrological and hydrometeorological studies to estimate if we have enough water in this reservoir, in the reservoir, and in this project. So, if you mention about the Wadi Deka Dam, in fact, we did these studies, so we should have enough water. And in the historical data, to don't have, you mentioned 5 years without rain in Oman. I'm not sure, but I'm not specialist hydrologist, but I'm not sure that we record that in the historically in Oman. However, we can decrease the evaporation with several solutions. Typically in America, they operate one asset with some plastic plastic ball, floating plastic ball to cover the reservoir. You have other solution, and we are working on it with our engineering. However, one last question. I don't know if we have this question. You have to take into account the climate change effect on the availability of water is an issue for us. So, in fact, we have at EDF our own hydrometeorological engineering with well-known worldwide, and we have some specific model for the climate change impact on the hydrology, and we use it for all of our projects. And in the international hydropower community, it's quite common to use this kind of model to verify that we will have enough water during the time of the operation of this project. Thank you.
Thank you, Florent. Our next question is, for the Hatta project, what is the charge/discharge events frequency in a day?
Every day. In fact, I think that in Middle East, it will be a daily storage. So, of course, you can have, I will say, 2 charge and 2 discharge per day maximum, but I think it's quite useful to target that. You can do more. So, in fact, in all the pump hydro storage in Middle East, the PPA will be navigability capacity, capacity PPA. So, in fact, it's based on the availability of the asset. So, the off-taker pay for the availability of the asset. So, in fact, you can use it more. So, if you want to use it with 5 or 10 discharge per day, it's possible. Of course, you have to border it to don't increase the aging of the equipment. However, it shouldn't be useful to do that, in fact. So I think between 1 discharge event or until 3 or 4 per day, it's enough in Middle East. It's my personal opinion.
Okay, awesome. Our next question is, what is expected at the end of the development period of Hatta project?
I don't understand well what is the development period. In fact, we will transfer this asset to DIWA, and DIWA will operate it.
Okay. Our next question
is it's important to mention. I don't know if it's the transfer of the project after the lifetime of this project, but in fact, in hydropower, we like to say that we don't have to do some decommissioning of the asset. When you are building a house in France and abroad, in fact, when we built a large dam, in fact, we can rehabilitate it until very long term because it depends of the cost of this rehabilitation, of course, but you can use it until 200 years, 300 years, we will see. So in fact, it's very, very long-term project.
Amazing. Thank you, Yves-Laurent. Our next question is, could you explain more about the powerhouse operating principle?
Okay. I don't know what do you want to. In fact, I didn't mention it, but I'm not sure that it's what you want. But in fact, in the powerhouse, so the pump hydro storage is the same hydraulic circuit with the same pump turbine. So it's not a pump and a separate turbine. It's mainly a technology with a pump turbine. In one rotation direction, in fact, you are pumping, and in the other rotating direction, in fact, you turbine the water. But I don't want what do you expect. But I'm glad to discuss with you after this session if needed.
Okay. Someone asked, would you kindly highlight your KSA projects pipeline?
Okay. I'm sorry to laugh, but in fact, we had one project in pipeline who was a Nestor project for NEOM. So we work with ENOA and we did the site screening, all the design studies, and we were ready to bid for this project as a developer. And we had one developer consortium for this project, but they freeze the RFP for this project. So it was a 2 gigawatt pump hydro storage project in NEOM area. Whether you have other projects in KSA, we are in link with the Ministry of Water and with the Ministry of Energy, and of course with SPPC, who is the principal buyer about this project, and we are waiting for any push on this kind of project, and we are waiting for an RFP, in fact, a competitive process. But we are quite sure that in KSA, we are convinced that in KSA we have a real need of storage, and you can see the number of batteries, a BSS project what you have, and for the sovereignty of the country, it should be a good idea to diversify the storage technology for electricity, and we are sure that in KSA they are thinking about some pump hydro storage projects.
Amazing. Thank you, Yves-Laurent. The next question is, how do you expect the capital cost of pumped hydro storage to evolve over the next 10 to 20 years, and what factors will have the greatest influence on these costs?
Okay. In fact, to be honest, hydropower is quite conservative. So in fact, the cost won't evaluate a lot. We have to optimize the project, and I'm sure that you have more and more competitive projects due to the competition with the BSS, because BSS aujourd'hui, so the electrochemical batteries, industrial electrochemical batteries. And I think BSS are more and more storage capacity. They are more and more sustainable or long lifetime, I will say. So in fact, we will have some competition between pump hydro storage and BSS. But in my opinion, it's fully complementary. You have a complementary between BSS and PHS. So in fact, we have to develop some PHS projects who is closest to the tariff of the batteries. As I say, close, it could be maybe 5% more or something like that. However, you invest for 100 years and you invest for the next generation with a sovereignty and with a local content, as I mentioned, and so on. So I think it will be the way. And for the capital cost, in fact, so you won't have, I think, some pumped hydro storage at high cost. So we will optimize this project to fit to the battery cost. And one thing is compared to the battery, in fact, we are not sensitive to the raw material cost and to the Chinese market. And in fact, when you are building pumped hydro storage, in fact, it's dependent only to civil works. So it's very simple materials such as earth, concrete, and steel. And of course, you need the electromechanical equipment and specific one.
Okay. Now the next question is, how do you secure revenues for these projects? Are they merchant or covered by PPAs?
So as I mentioned, it's a PPA, it's a capacity PPA paid on the availability of the asset. And of course, you have a fixed tariff and you can have a variable revenue. A part of this revenue could be variable.
Awesome. Our next question is, can you share your thoughts of BESS versus pumped hydro storage, considering economical/public versus financial/private perspective?
Okay, I think I gave the response to this question before. So as I mentioned, in fact, BSS and PHS should be you have a complementary between both of them, and the PHS is for more long term, and for BSS, in fact, the lifetime of the BSS is around 20 to 25 years. In fact, you have some EPC who mentioned that you can use it for 25 years, but we are waiting the return of experience on it. However, in fact, we have to fit the tariff of the PHS with the BSS, of course.
Okay. Now the next question. Can pumped hydropower storage systems be feasibly implemented at existing small dam facilities?
What is small dam and what is the capacity? It depends on the bankability of this project, in fact, and the tariff, of course. I like to say, in fact, the cost of one pumped hydro storage will depend on several parameters. The main parameter is civil works. So it's a variable parameter, of course, because it's very site specific. If you have a long distance between the both reservoirs, of course, the tunnel will cost more. If you have to build a smaller dam, but you can have a big reservoir retained by the smaller dam, of course, it's a more bankable project. So in fact, it depends on the site and the civil works, I would say. So if you have any small dam with a huge reservoir, in fact, and with closest second reservoir, in fact, it could be useful to study this project.
Okay. Our next question is, we consume some power to send water back, right? The RTE mentioned 80% is including this auxiliary power consumption.
Yes, it's exactly so. In fact, it's a mean. So okay, the round trip efficiency is between 75% to 83% for the better one, ISO. So in fact, we can mention we are close to 80%, and typically in HATA we are at 80% of the round trip efficiency. And we include the auxiliary power consumption. Yeah, fully right. So compared to batteries, it's important to mention it. In batteries, you are around 85%, including the auxiliary power consumption. So we are not too far. We are under, but we are not too far in hydropower.
Okay, next question is, how much energy is required to pump back same amount of water, which can be used to produce same amount of energy, say 1 megawatt hour?
80%. I leave you to do the calculation.
Okay. The next one now is which economical battery which is economical battery storage or pumped storage? Oh, I'm afraid I don't really understand this question, so we can skip. All right. Have you ever worked on a project to convert a conventional hydroelectric power plant into a pumped storage hydroelectric power plant? For instance, the Uluabat hydroelectric power plant in Turkey has a reservoir and its tail race discharges directly into a natural river.
Interesting. I'm sorry, I have an issue with my camera, but it doesn't matter. I relaunch it every time, but I will relaunch it. In fact, it's interesting. So I don't know Uluabat hydroelectric power plant, I'm sorry, in Turkey. However, we fully work in the conversion of conventional hydroelectric power plant to a pump hydro storage, and we have this kind of project in France at EDF, typically.
Okay. Will this kind of project be feasible if the land terrain is a flat basin?
Okay. We need elevation, in fact, because we need a gross height between the lower reservoir and the upper reservoir. However, you have some project with open pit mining, typically in Australia, where you have some developer who are thinking to reuse the mining as the lower reservoir, and they will build the upper reservoir in the flatland terrain. So it could be feasible. I let you to work on it and to develop this kind of project, and maybe to come back to us if you think that it's feasible.
Okay. Next question is, what is the approximate percentage difference in CapEx and OpEx between a battery energy storage system project and a pumped hydro storage project for the same capacity?
Okay. So, in fact, it's quite the same cost if you take into account the renewal of the batteries for the same lifetime. So if you do the calculation on the same lifetime base, in fact, it's quite the same cost between an optimized pump hydro storage project and BSS for 1 gigawatt of storage for 8 hours, for example. We did this calculation, and the LCOS, so leverage cost of energy storage, is very similar.
Okay. Next question is, what is the duration of the development phase of a hydropower project? Actions before having activities of construction at site.
So as I mentioned, in fact, the origination phase could take between 1 to 3 years, and the development phase could be between 1 to 3 years too. So in fact, you are between 2 to 6 years, if I may. It depends of the country, of the permitting, of the different issue what you have to face, such as a geological issue or ENS issue. And it depends of the financer. If you have some banks and or DFI who are involving in this project, in fact, you can add sometimes.
Okay. Next question. With the massive influx of solar PV across the Middle East, how does EDF see the interplay between pumped storage, hydropower, and large-scale battery energy storage systems? Are they competing, or do they complement each other in your net zero strategy?
They are fully complement,
Yes.
as I mentioned before. Yeah.
Okay. Any other hydro project expected beyond KSA and Oman?
Yes. Yes, yes. We think that you have a huge need of storage due to the rise of the energy, solar PV energy, in fact, and renewable energy globally. In fact, you need flexibility, you need storage. So, in fact, you should have any storage project, such as batteries, such as PHS, or maybe other technologies too. And we are sure that in KSA and in Oman, you will have other projects. And typically in Oman, you have several mountain area distributed on the surface of the country. So in fact, and on the grid, I would say. So in fact, you should have other project after this first project. I think so. And in KSA, it's quite the same. SPPC, just for your mind, SPPC launched a tender for 8 gigawatt hour of BSS last year. Of BSS. So in fact, they need storage, and they will continue to launch some tender for BSS, and they are thinking about PHS too.
All right. The next question is, what is the upcoming breakthrough or innovation that you see coming?
I think the variable speed pump turbine is an innovation in hydropower, and I will focus on the hydropower. I'm sorry, but I don't want to speak about the other project of storage projects and so on. And the second innovation could be the reduction of the evaporation of water in Middle East, in arid region. So we have to work on this kind of solution. And of course, you have a lot of people who are thinking to optimize, to decrease the evaporation by cover the reservoir by some floating PV and use the electricity produced by this floating PV. However, we test this technology. We have this technology in France, and we test it industrially. And in some times, in fact, you can increase the evaporation due to the solar PV. Because if you don't cover fully the reservoir, in fact, you will increase the temperature of the reservoir and you can increase the evaporation. Of course, the albedo decrease, but you will increase the temperature of the reservoir. And the second thing is the wind could increase the evaporation. So in fact, we have to protect to the sun and to the albedo and to protect to the wind. So in fact, the convection could increase the evaporation. So we have to work on it and maybe to find the right solution for each reservoir what we want to build. And especially for the desalinized water project where we have to buy some water.
Okay. All right, we are running out of time, so I think we're going to wrap this up. Thank you very much, Yves-Laurent, for all of your insights, and thank you everyone for attending today's event. Of course, once you leave today's event, you will receive a survey on the presentation, and we would really appreciate it if you would provide your feedback. You will also receive a follow-up email within 24 to 48 hours with a link to view a recording of today's event. If you have any additional questions, please feel free to reach out to us. Of course, any questions that we did not answer, we will try to reach out to you personally and answer them. And yeah, thank you again, Yves-Laurent, and to all of you for joining us today on behalf of EDF Middle East, and have a great rest of your day. Thank you very much.
Thank you very much.